Okay, here's a diagram that depicts the situation. We've got this river, and we're going to create a rectangular plot of land along that river with 764 feet of fencing. So this is kind of what the diagram looks like. I used the letters W and L to represent the dimensions of the rectangle. And so we know that L plus 2W adds up to 764. That's the perimeter, or the length of fencing that we have. And I, for some reason, chose to solve for W. You could have easily solved for L and done the same thing. But the formula for the area of that rectangle is A times width. And if we can get that A in terms of one of the letters, either L or W, well, let's see what happens. Since W is 382 minus 1/2 L, I can substitute that in here. And L equals 380, L times the quantity 382 minus 1/2 L. If I distribute the L, this is what I get. And I rewrote it with this L squared term first. So there's A, the area of that plot of land, as a function of the length. And that looks like the equation or the function for a parabola, downward opening, because the numerical coefficient of L squared is negative. So we got a downward opening parabola. Looks maybe something like this. If we could find its vertex, that would be the L value that gave us the maximum area. And the vertex of a parabola lies on the axis of symmetry, and a formula for the axis of symmetry is the opposite of B over 2A. There's other ways to locate the x-coordinate of the vertex, but this is probably the easiest one. So since L is the independent variable, the opposite of B would be opposite of 382 over 2. A is negative 1/2. 2 times negative 1/2 is negative 1. So the idea is that when the length is 382, we will get the maximum area because the vertex occurs when L equals 382. And whoops, this should have been, I didn't know what I wrote here. Half of 382 is 191, not 391. Okay, so let's go over here to Desmo so you can see what's happening. This is the water. This is the length. This is the length down here at 382. It looks like that gives us a maximum area of 72,962 square units, whatever they were. Okay, and if I shift this point this way, the area is smaller and smaller. If I go the other way, the area is smaller. So it's at 382 that we get the maximum area, right about there. Okay, and if I want to actually, what happened here? Okay, I was going to try to show the parabola, but it looks like my little thing's not working there. So anyway, the vertex of the parabola occurs again when x is 382. There's the maximum area right there. You can see any other dimension for the length gives us a smaller area. There you go. Hope that helped. If you have any questions, post a comment.